Hello everybody, today I want to talk about libav. This is the library of FFmpeg, and FFmpeg it's a command line program for decoding and encoding different types of video. So I want to start series about FFmpeg and explain how to use FFmpeg programmatically, how to use library of FFmpeg. So what is, I did not program for video encoding for a long time. I do this thing occasionally, and in fact this video is recorded using my software. I have like kind of video edit, and there is a small program, screen capture. It's very small, it's like 300 lines to capture video, and actually I have some video on the side. You can see like this is the program which is recording my video, and so I do this thing, and I do like some tricks to make it fast. I like spawning threads, anyways, and also on the way of doing all these kind of tutorials, I hoping to make the C++ wrapper for FFmpeg, because every time then I need to do video encoding, I kind of forgetting how to use FFmpeg, and hopefully having a good C++ wrapper around this thing will help me to do all different small projects. So let's start. Let me create the directory, and idea is making the wrapper for FFmpeg. Let's call it libav++, not to be very original. So we will have main.cpp, and probably we will include. So FFmpeg library consists of different modules, and let me show you on internet. So FFmpeg, right? So we can open it here, and there is a documentation, and here is it, library documentation. So it has multiple modules kind of divided by different things. So it has utils, it has scale library, it has resample library, it has codec, and it has format, and also it has device and filter. So I will talk about these two libraries, format and codec. So let's talk about format first. So format is allowing, the library is allowing to open different types of files like MOV, MPEG-4, MP3, JPEG, like, and also it's doing multiplexing and demultiplexing of files. So for this library, all files are kind of containers which are having streams. I don't know, let me try to draw. Let me open GIMP. So let me try to draw for you. So we have like file, right? And inside the file we like can have multiple streams. Stream 1, stream 2, 3, right? And each stream, it might be a stream of like video stream, it might be audio stream, or subtitle stream. So and inside each stream we can have like compressed packages, and like for video stream normally each package represents like one frame, and like also we can have audio packages, and each audio package normally represents like some sort of number of samples, and each package also has embedded meta information like timestamps and resolution of the frame, and audio package also can have timestamp, like number of samples inside, and other things. And I did not work too much with subtitles stream, so I don't know exactly what it can have. And this kind of things a little bit messy with subtitles, because closed captions are actually not the part of the stream, the separate stream. It's a part of the video stream, but it's fine. Anyways, let's see how we can do things programmatically. So and because I do not remember things, I probably will open the another version of Emacs on the side and see how did I do. Like, for instance, as example, I will use my video editor capturing thing, probably. Let me think. Yeah, screen capture actually does not use any files, but anyways, it will give me some ideas. So first I need to include format, right? libav format.h. So let me try to compile it. Let me keep it just so it does compile. So in Linux it compiles with these options. So like compiling, you just compile normally, and then you need to add IV codec, IV format, and IV utils, and depends of what you are using. I think just for sake of simplicity, I'm linking against all of these libraries, but like normally you just need to link against AV format and we should be good to go. So next thing what you need to do, you need to kind of open the file, right? And to open your file you need to create format context. So AV format context, and right at very beginning you need to register different formats. And what you can do, you can just register all with AV register all, or if you want to save some resources, you can do AV format register all, or if you want to just mess around with codec, you can do AV codec register all. But like for simplicity, you can just do AV register all. Now you need to have some context. AV format context, and it's a pointer. And let me open some different So next thing what you need to do, it's try to open the file. So to open the file you need to run AV format open input, and here's it, you need to give the pointer to format context and then file name. And there is two other parameters. Normally it's just null pointer, but we can just Google for this call. Let's just Google. AV format open input. So here's it, you need to provide input format and dictionary. So so if you want to force format, you can specify it like in the input format, and sometimes it's useful. For instance, there is a lot of files do not have meta information embedded, even like sometimes you can figure out by extension, right? Or a lot of files have header information at beginning, but some files are like really raw files. Like for instance, uncompressed audio stream may be this kind of example, and you may specify import format here. And dictionary, you can provide some different types of options. For example, like file name might not be a direct file name, it might be pointer to device, and with dictionary you can provide some extra information how to configure the device. Like you have a web camera and you might specify a number of frames per second or resolution or some other parameters to your web camera. So, but like for file and for auto detect, you can provide null pointer, and we should be good. And let's give some file name. Have plenty of files, so let's see. So I have a lot of log files, right? So it's in, I think it's in vlog directory or video or movies. Let me find it out. Oh, here's it. iPhone photo backup, right? And here I have a lot of files like this. So let me provide the link to any of these files. So let's see, undefined reference. Yeah, so the problem here, I am compiling this thing with C++, and AV format, libav is pure C library. So what I need to do, I need to specify extern C, so to tell compiler what we are including is actually C include extern C, so it will help. Right, so now we check for result, and we can go to our documentation and see what it says. Return 0 on success, negative AV error or failure. So if it's not equal 0, we do like std error. So I need to include string error open file, and probably I'll need to put file name here, and an open file this error code this, and return some value. Okay, so let's see how would it work. It's actually segfaulted, and it's segfaulted because this thing actually has to be initialized as null pointer. Now it's worked. So let's try to, like, this is existing file, and let's try to put not existing file and see how it will behave. So it says error open file, error code -2. So unfortunately documentation doesn't have too much information like how to know what does mean -2. Let's see examples. Yeah, it didn't say anything. Anyways, so we were able to open file, and next thing it's close it, right? So AV format, to close it we need to do AV format free context. AV format free context, and format context like this. Let's try to run it again. Yeah, it's giving the error because of this thing. Now it's good. So what I want to do, I want to encapsulate all this code inside the class, and let's have class format, probably hpp on class format, and it will have this thing, and it will have this thing here, and as constructor it will take file name, and that's it for now, and it will have destructor. So here in constructor I will have these 3 lines, file name .c string, format context, and here I will throw exception, std time error, yeah, stream. I think it's just S stream, right? And here's it, std o string strum, put strum here and do strum there, like this, and we do not need to have this thing. Alright, we need to include string here. We do not need std here. AV register. All right, so we actually should not have AV register. Oh yeah, but let's keep it still here. And what I will have format. Yeah, so I need to include here include format.hpp format and file name, and that's it, like this for format. Okay, so it should behave exactly the same. So let's see if I make the wrong file name. Yeah, it did throw exception. Okay, good. So next thing, then we have format. We can extract streams in the format. So to extract streams from the format, you can run first AV format find stream info against the format context. So like then you did AV format open info input, it just opened the file and did not do anything else. As soon as you run AV format find stream info, it will populate this structure with string information. So I can do it here. Result equals AV format stream info text, and also it will take some parameter, and let's see what is it. Find stream info, and also it takes some options dictionary. So let's keep it null for now. Again, I think I'll just copy paste this code. Error find stream info for file name, error code. So we get stream info, and actually we can dump now this thing. There is a special function dump format, and so there is a bunch of parameters. I don't know why AV format open input did not save file name, so it's actually lost, like it's not saved inside format context. So if I want to dump, I need to give file name. Let's see documentation about this system call. AV dump format URL and is output. So to analyze index of the stream to dump information about, such as source of destination file, specified input or output. So 0 is input and 1 is output. And yeah, and our context is input context, and also index of stream to dump information about 0. So let's see what we will have now. So it did dump information, and you can see like creation time, duration, bitrate, all different information like audio, what codec used to compress the audio stream, and all these kind of things. So this is just a helper tool here, and we can extract all this information manually. So to know like number of streams, it will have like NB streams populated. So let's have things like let me think, what is AV format context. AV format context. Streams, and it's unsigned, right? So let's have unsigned number of streams. So this function will return number of streams, and it's from format context. And actually, let me rename it to context because it's a class format, and yeah, context and b streams. So we can now print out td out number of streams format and b streams. Number of streams 4, and let's verify this thing. 1 2 3 4, right? So now we can have stream, and we can just have the class stream class stream, and private will have pointer to stream, and be streams, right? So AV stream, it's pointer to pointer, huh? Right, because it's array. So, and also I need to include here format. So let me think how I want to encapsulate thing. So obviously I will have some sort of access function here, right? And I can return the stream here, right? Streams, like, and here unsigned index. So I can return, also I can just return pointer here and have here vector of streams, and then I run this thing. I can pre-populate this vector here. Yeah, I think I will go this way. So for auto I equals 0, I less than plus I, and then I'm going to streams push back stream. I think I'll do place back, and I will give streams I, and then I need to make friend format, right? And here I'll do class stream, forward definition of stream. I need vector streams and b streams list, right? And this thing will have pointer to streams list x. To incomplete, right? So here I need to include stream.hpp. It's private, stream hpp is private, required from here, but format is friend class format, right, from here. Yeah, let's make it public, right? So I did not make the constructor. Yep, we're good. So now here we can do for I 0, I less than format streams, I auto stream equal format dot streams I here. Okay, so what kind of I said stream might be audio stream or video stream or it might be three types, right? So here's it. Where is the type? Let me see. And actually it's determined by codec, and it can have this kind of types: video, audio, data, subtitle, attachment, and NB. I have no idea. And unknown. So I don't know why it's have like so many layers, but it's embedded inside the codec context, which has codec, and codec have type. So our kind of useful information, it's duration, number of frames. Also for video it might have sample aspect ratio, average frame rate, and yeah, all this information is kind of estimation, because like let's see, what did it say? Duration will be estimated, right, based on bitrate and file size. Number of frames, same thing, number of frames in the stream if known, 0 or 0 if unknown. Like stream might be like stream, you know, it should not, might not have average frame rate. So all this information is basically approximation. And the most useful thing, it's codec context. So let's do, I don't know how I would do, like probably I would do this thing like layered as in FFmpeg, but for me it doesn't make any sense to have different layers. So let's embed everything in the stream. And also I don't want to have some approximations, so probably I would not expose all these values right now. So what else? Yeah, I don't know, I can have enumeration about stream, right? Like it can return type, and type is codec type, AV media type enumeration, right? AV media type. So it can return type, but also I can do different things. I can just can make like a base stream and then derive like audio stream and then video stream. I can do it like this, and here in main function I can do if stream and try to do dynamic cast. If cast to audio stream like this, I video, something like this. Probably I'll do it like this. Yeah, let me do it like this. So public audio stream. I think C++11 has some feature. I do not remember the name of the feature. C++11 constructor inheritance. Yeah, using BB, yeah. Okay, so I can do using base stream like this. Right, and now because of all this virtualization, first I need to have base stream virtual default, and all these things should be pointers, and pointer include memory streams, and here I should do get, and here I do push back td make for stream. Stream, yeah, so this one actually base stream, and here it's depending of the type. Context streams I codec type, and I can put this thing in switch case AV media type video stream, audio stream. For default I'll do base stream codec type audio base stream include stream.hpp. Cannot dynamic cast. Oh, I missed star. Anyways, let's see how it's gonna work. So it's have 4 streams. First is video, second is audio, and these 2 things unknown, and like let's do unknown, right? Else known type stream. Video, audio, unknown. Yeah, fair enough. So what else we want to have? So from then we got the format. We can read frames, packages from it. So let's have so we can have package, and we can read it from the format, like from the file. So let's implement it here. So, and all these packages are kind of belong to different streams, but we kind of do not know in advance to which stream it's belong to. So for this reason we kind of, not we, but like designers of FFmpeg decided to read from format. So, and to read from format we need to do call read read frame. Packet. So in here AV packet, like this, checking for errors, we read frame. So result should be 0. If it's not 0, I'll print error read frame. Otherwise I will construct packet. Looks like I need to construct shared pointers, right? Let me think. I think it's a good candidate for shared pointers because or actually I do not need I mean I can, yeah, so it should return unique pointer of packet. So std pointer packet, let me think. Yeah, I think it's right. So here packet std unique pointer result, and result.packet and return result. Yeah, sounds right. Okay, now packet.hpp pragma once plus packet, and similar as format, I'll need to include this thing, and here I will have a v packet and going to be public. I'll make format friend and class format. Yeah, we good. So right, read will return unique pointer of packet, and we are not throwing exception here. Let me read the documentation. Read frame, error on or end of file. If OK, less than 0 on error on end of file. How to know is it error or end of file? I think throwing exception at the end of file, it's kind of fine. Okay, let's throw exception. Probably it's better to return null pointer, but I don't know how to distinguish between end of file and error, so I'll just throw exception for now. Probably later I will distinguish, and if it's error, throw exception. If it's end of file, return null pointer. Class packet, context not declared. What? Oh yeah, format, because res is unique pointer. std make unique, and actually I can make it auto, right? Yeah, need to include packet, file name, read frame. I don't have file name information either. So try, yeah, I'll just do it for, so infinite loop auto packet equals format dot read. So let's see, I need to do move, where I need to do move, here, td move. Alright, do I need to do move? I don't need to do move, right? I should not need to do move, logically. So where did I do this thing? In format, right? I don't need to do move. Logically it's should figure out. Yeah, it did figure out. So let's see. Error code. Main auto I equals 0 plus I td cout frame I std endo. How many frames? 1 for 26, and like totally bogus error code. Yeah. Anyways, I think that's it for now. Hopefully I will continue this series of kind of tutorial explanation and writing the library videos. Thank you for watching, and yeah, hopefully see you next time. Bye.